Alright, good day students. Welcome to the Microsoft Academy. So we have a question on modern physics. So we are looking at three questions here. Question 1, question 2, and question 3. So let's start with our question 1. So in question 1, we are asked to calculate the third excited state of hydrogen atom, and the instruction is to leave the answer in what? In joules. So how do we calculate the third excitation of the hydrogen atom? So we have that from the formula, the third excitation energy is given as minus 13.6 all over n squared, and the answer is in electron volts. So this energy, En, depends on the excitation states that we are looking at. So since we are looking at the third excitation state, there's a difference between the third orbital or the third energy level and the third excited state. The third excited state is the fourth energy level, which is where our n is equal to what? To 4. So anywhere I see n, I substitute what? 4 for the third excited state. So the third excited state is the fourth orbital. So if we substitute, we are going to have that E4 will be equal to minus 13.6 all over n. Our n is 4. Remember the formula says square it, so we square it. So if you should solve this, it will be in electron volts. So when we solve our answer in electron volts, we got it as minus 0.85 electron volts. But the question says leave your answer in joules. So but our answer is in electron volts. So we have to convert from electron volts to what? To joules. So how do we convert? Very simple. Our E4 will be equal to minus 0.85 times this electron volt. 1 electron volt is 1.6 times 10 raised to the power minus 19 joules. So that is the conversion. So if I multiply this with this, you point that in your calculator to give you minus 1.36 times 10 raised to the power minus 19 joules. So that gives us the energy in the third excited state of what? Hydrogen. So that's how you solve it. So if they ask for the fourth excited state, our n will be equal to 5. But if I ask you to get the energy in the third orbital or third energy level is n equal to 3. So it's different from saying the third excited world state. I hope that is clear. Alright, so let's move to the next question. Now question 2, it says calculate the wavelength of photon with energy of 0.65 million electron volts. So what we want to do in this question is to get the wavelength when we are giving the what? The energy of the photon. What is the energy of the photon? The energy of the photon is given mathematically as h what? F. So which we can as well write it as h c all over what? Lambda. Because c over lambda is equal to the what? To the frequency. So if you make your substitution, you should get that. So I will be using this in the calculation. So where you see E equals to the whole of this, one can make lambda the subject formula. Lambda will come over to this place and E will come over to this place. So you can see clearly that lambda is equal to hc all over what? E. Now, h is called the Planck's constant, c is the speed of the radiation, which is a constant also, 3 times 10 raised to the power what? 8. And E is the energy given. But there's a problem. Our E is given in million electron volts, and we are expected to leave the answer of E in joules. So what do? We are going to do a conversion, but let's make the substitution for the Planck's constant. Is a constant and is given as 6.63 times 10 raised to the power minus 34. So that is the Planck's constant. Then times the speed of the radiation. The speed of the photon is 3 times 10 raised to the power 8 meter per second, all divided by the energy. So the energy is given as 0.65, then times million. Million means 10 raised to the power 6. Then times our electron volts in joules is 1.6 times 10 raised to the power minus 19 joules. So you must do this conversion anytime you use HC as this. your energy must be in watts, in joules. Now, with this, we can find the lambda. If you punch your calculator, you will get that lambda is equal to 1.91 times 10 raised to power minus 12 meters. So that is the wavelength. One can still write the answer as 1.91, then picometers. So pico here is 10 raised to power minus what? 12. So that is the wavelength. So depending on the option, you should know how to leave your answer. Alright, so let's quickly move to the next question. So question 3 talks about the wavelength when we are given spectral lines emitted by hydrogen atom during a transition state from the 4th energy level to the 3rd energy level. And we are given the different energy values as E4 equal to this and E3 equal to that. So now, how do we get the wavelength? So the theory here is that the energy is equal to the difference in the transition states, that is from the 4th state to the 3rd state, which is simply having E4 minus E3. So the difference between these energy states will give us the the photon energy. So in that case, I can also, we have our E4 in the question, we have our E3. So, but we have energy as, remember we said energy is equal to Hc all over what? Lambda. So that's our energy. So let's get the energy, then we'll find the wavelength, because the question is to find our wavelength. So with this, you can see that the energy is our E4, which is minus 1.3 times 10 raised to power minus 19, minus E3, which also have a minus, so we have minus 2.4 times 10 raised to power minus 19. So that will give us our E. So that means if you punch in your calculator, remember minus times minus will make it to be plus, right? So we have minus this plus this. So if you punch that in your calculator to give you 1.1 times 10 raised to power minus 19 joules. So what we have here is the energy. So remember, to get your wavelength, you make lambda the subject formula. So our lambda becomes equal to Hc all over E. So that means to get my lambda, I'll be having lambda is Hc all over C, all over E. So if you substitute, you have your H is a constant, Planck's constant is 6.63 times 10 raised to power minus 19 times C, which is the speed of light. So the speed of light is 3 times 10 raised to power 8 all over the energy, which we just calculated as 1.1 times 10 raised to power minus 19 joules. So if you punch that in your calculator, this will give us about 1802 times 10 raised to power minus 9 meters. So that is the wavelength. So that is how you get the wavelength for different transition. So you have seen in summary that this is how you get the energy for the hydrogen atom for different states, and this is how you get the wavelength of the photon if you are given the energy, and this is how you get the wavelength of the hydrogen atom or photon when you are given the different transition energy level. So that is how you solve it. So this will revise on your modern physics. So we also look at your wave thermal physics as well in other videos. These are for exam revision. Once you're able to know this, you'll be able to pass the exam concerning electromagnetism, modern physics, wave thermal physics, and the rest of them. So see you in the next class. If you have not subscribed, do well to subscribe as well. Thank you.